Welcome back to the course. As last week we learned about the basics of quadratic equation, today we'll be looking at something more complex, which is solving it in real-life context. This is a problem. In badminton, players cannot serve above the short serve line over here, and the shuttlecock has to pass the serve line of the opposite course as well, which is over here. The distance from the short serve line to the net is 1.98 meters, and the height of the net is 1.524 meter. The height of the player's waist to the ground is 1 meter. The net is exactly between the two serve lines, and in fact, it is the axis of symmetry. In a tournament, player Mr. J is doing a short serve from one court side to the other with the given equation over here. So the first question is, create a real-life context model and graph of the equation. State the problem of the given quadratic equation. I convert the standard form to vertex form to graph. The problem with this quadratic equation is that when convert the equation to vertex form, it can be seen that the maximum value of the equation is 1.5, which indicates that the shuttlecock will not pass the net since the height of the net is 1.524. Now let's look at the second problem. Write a new equation that suits the context of the problem. Answer it in standard form, create a model representation in graph of the parabola, identify the reasons of the change made, and justify your answer accordingly to real-life context. So the approach here is to make the shuttlecock to pass the net. First of all, we have to identify the relevant information, which are height of the net, which is 1.524 meter, height of the player's waist, which is 1 meter. The net is exactly between the two short serve lines, and it indicates the axis of symmetry of the parabola. Next is the distance from the net to the short serve line, which is 1.98 meters. When it comes to solving the equation, first of all, we have to find the axis of symmetry, which it is the midpoint between the two short serve lines, in which the x1 is 0 and the x2 is 1.98 times 2, which is 3.96, and it can be round up to 4. So therefore the midpoint is 4 plus 0 divided by 2, which is 2. Then I plug this into the vertex form. For the value of k, I substituted 1.8 because it can actually be anything that is above 1.524 in order for it to pass through the net. The next step is to find a. I substituted 0 and 1, which is the y-intercept, into the vertex form in order to find a, which the answer is negative 0.2. Here's the new vertex form of the new equation. However, they asked for the standard form, so I have to expand it and turn it to a standard form, in which the answer is negative 0.2 power by 2 plus 0.8x plus 1. This is the model of the equation found, and this is the graph of the model. The key points includes the maximum points and the y-intercept. For the verification, I substitute the a and b value of the answer found from the axis of symmetry, and it is equal to the midpoint we found. According to the given question, the height of the net is 1.524 meters. Therefore, in order for the shuttlecock to pass the net, the maximum value has to be greater than 1.524 meters, but not too high, because if the shuttlecock landed too high, the opponent can easily smash it and the player can lose advantage in the round. Thus, the maximum height of 1.8 meter is an appropriate approach in real-life context. In addition, in real-life context, the graph shouldn't be perpetual since it should come to an end when the shuttlecock hits the ground. Therefore, I set the domain from the serving and landing point, and set the range from the ground to the maximum value. When compared the new equation to the original equation, it can be seen that the a value of the new one is greater. This suits the real-life context since x and y intercepts cannot be changed in the context of the question. When related to the real-life context, according to the rule and regulation of badminton, when serving a shuttlecock, it cannot be higher than the player's waist. Therefore, the maximum value of the y-intercept their waist height, which is 1 meter. In the other word, the player has to serve the shuttlecock more safely so that it can pass the net, since he cannot move the shuttlecock any higher from his body, as it will be against the rule and regulation of badminton. One section that should be improved is the filming of the model of the second equation, in which it is tilted slightly to the right since it cannot be fitted to 90 degrees. So therefore there might be some estimation in the graph that might not be as accurate. These are the works I did, and this is all for today's lesson, guys. Have a nice day.